In this video, I'm going to talk about cubic system or common cubic structures. The cubic crystal system is one of the most common and by far the simplest class of crystals. As the name itself suggests, all the crystal structures of this system have a cubic shaped unit. Under this topic, these two subtopics will be discussed: three common representatives and determination of the number of atoms in each cubic structure. Let's see what are the three main common representatives. First one is the simple cubic structure or primitive cubic structure. This is the simplest form of cubic structure. Next one, the body-centered cubic structure or BCC. Third one, the face-centered cubic structure or FCC. Let's move on to the simple cubic structure, SC or primitive cubic structure. Here there are cone atoms, and one cone atom is shared by 8 unit cells. So you should be able to visualize these things. The simple cubic unit cell delineated by 8 atoms, which mark the actual cube. These are cone atoms, so each one only contributes 1/8 of an atom to the unit cell, thus giving us only one net atom. So contribution of this atom to this unit cell is 1/8 or 1/8. So when 1/8 multiplied by 1/8 multiplied by 8, because there are 8 cone atoms, 1, 2, 3, 4, 5, 6, 7, 8. When 1/8 multiplied by 8, it's 1. So thus giving us only one net atom. Determine the number of atoms in a simple cubic structure. So how to determine it? Let's see. Number of cone atoms equals to 8. In previous case, we saw that 1, 2, 3, 4, 5, 6, 7, 8. It's 8. Then cone atoms contribution to the unit cell 1/8. We discussed it earlier. This one cone atom is shared by 8 cells. So the contribution of this cone atom to this unit cell is 1/8. Here it is. Cone atom's contribution to the unit cell equals to 1/8. Therefore, the number of atoms equals to 1/8 multiplied by 8. Cone atom's contribution to the unit cell 1/8, and there are 8 cone atoms, so the total number of atoms here is 1/8. 1/8 multiplied by 8 equals to 1. So the answer is 1. Next, the body-centered cubic structure, BCC. The next or the second representative. This is the picture of the body-centered cubic structure, and this is the 3D appearance. So, a body-centered cubic unit cell structure consists of atoms arranged in a cube where each corner of the cube shares an atom and with one atom positioned at the center. The body-centered cubic structure is based on the simple cubic structure but has an additional lattice point at the very center of the cube. So it is almost like the simple cubic structure, but the only difference is here there is one lattice point inside the cube. So there are 8 corner atoms and as well as one lattice point in the middle. Let's see how to determine the number of atoms in a body-centered cubic structure or BCC. Number of corner atoms 8, because there are 8 number of corner atoms 1, 2, 3, 4, 5, 6, 7, 8. Corner atoms contribution to the unit cell 1 by 8. Again, this one atom is shared by 8 cells, so the contribution to this corner atom for this unit cell is 1 by 8 or 1/8. So corner atoms contribution to the unit cell 1 by 8. Then number of entirely inside atoms 1. Here I told it before. There is one atom entirely inside this unit cell. So number of entirely inside atoms equals to 1. Then entirely inside atoms contribution to the unit cell is 1, because this is a full atom. So contribution of this to this unit cell is 1 because it is inside this unit cell. The entire atom is inside the unit cell. That's why. Entirely inside atoms contribution to the unit cell is 1. Therefore, total number of atoms equals to 1 by 8 multiplied by 8. Here 1 by 8 multiplied by 8 plus 1 multiplied by 1. Number of entire inside atoms equals to 1 and it should be multiplied by 1, and the answer is 2. Next one and the last one, the face-centered cubic structure or FCC. So this is also based on the simple cubic structure. Here the only difference between the simple cubic structure and the face-centered cubic structure is, in addition, there are 6 phase atoms. 1, 2, 3, 4, 5, 6. So this one phase atom is shared by 2 cells. Here one cell and there is another cell attached to this. So this one phase atom is shared by 2 atoms, 2 unit cells. So the contribution of this phase atom to this unit cell is 1 by 8 or half. In this crystal structure, there are the 8 lattice points at each corner as in the simple cubic, but there are additional lattice points at the center of each face of the cube. Here, determine the number of atoms in a face-centered cubic structure. Number of cone atoms equal to 8. 1, 2, 3, 4, 5, 6, 7, 8. Cone atoms contribution to the unit cell equals to 1 by 8. This entire atom is shared by 8 atoms. This unit cell we are talking is one of them. So the contribution is 1 by 8. Number of phase atoms. Again, 1, 2, 3, 4, 5, 6. Phase atoms contribution to the unit cell equals to 1 by 2 or half. This phase atom is shared by 2 atoms. So the contribution to this contribution of this phase atom to the unit cell is half. Therefore, total number of atoms equals to 1 by 8 multiplied by 8, 1 by 8 multiplied by 8 plus 1 by 2 multiplied by 6. There are 6 phase atoms. 1 by 2 multiplied by 6. So the total number is 4. So this is the end of the video. Give us a thumbs up if you like this video and subscribe to the Educate Today YouTube channel. Thank you.